Check. Hey, welcome everybody. Good afternoon to you. We are here today to talk about the Automotive IoT Revolution. So we're going to have a wonderful panel here of speakers that will explore the space with you. And then we will have some time at the end for some questions. So do be thinking about what you'd like to talk about. So I'll kick this off with a brief introduction and pass it on to my panelists here. My name is Sven Schrecker. I'm the Vice President of Cybersecurity at LHP Engineering Solutions. We are an automotive services company. I'm also the co-chair of the Security Working Group within the IIC. So, introductions, please.
Thank you, Sven. Hi, everybody. My name is Dirk Slauner. I work for Bosch Software Innovations. We are the IoT company of Bosch, which is a major player, obviously, in the automotive components space. And I'm also very actively working with the Industrial Internet Consortium, where I am the chairman of the steering committee. And I take a special interest, of course, in everything related to automotive and IoT.
And Jan?
Hi everybody, my name is Jan Görs. I work for Daimler and more specifically for the RD department or division of the Mercedes-Benz cars. And most of my 15 years there I've been developing production grade software for systems either for the production plant, for the vehicle, or now more and more for the back-end and for connected functions. And I'm actually responsible for most of the remote control functions for Mercedes-Benz cars and also the cloud transformation that we're going through.
Yes, thank you. So for this panel, I will represent the audience and kind of lead the conversation into what I think is most interesting, and certainly the conversation will wander. It will be quite fluid, so if you do have questions, again, we'll have some time at the end. I think the key to this particular session is that there is a massive evolution of technology within automotive. So there are four major drivers for this technology revolution. The case, right? We have the connected, autonomous, shared, and electrified, right? How do these play into your experience? How have these affected you most to begin with?
Mm-hmm. So first of all, these are the trends that are really highly important right now, and obviously they're driven or enabled by other technologies in there. 5G is an example, battery technology obviously is an example, and also you have advances for the autonomous driving or the highly automated driving, advances in sensors and sensor fusions. More related to what I'm working on, we have, for example, cloud enablement or enrichment. So you have cloud functionality enriching in-car functions like speech recognition. You can communicate with your car in natural language. But more and more also, I think the focus and the challenge is distributed functions, developing distributed functions inside the car and with different players like parking garages or like the charging stations and so on. So how do you develop and lifetime manage software there?
Dirk?
The way how I see it is Bosch as a company has been around for roughly 130 years, maybe even a little bit more. We started off, one of our first products was an ignition plug. Actually, our logo is an ignition plug. So our world has been relatively steady the last 130 years. And I would say in the last 5 to 10 years, everything has turned upside down. I think there's massive changes wherever you look, from business models to functionality to supply chain to the organization to how we work, etc. I mean, in the old days, so to say, we had the OEMs, we had the tier 1s, we had the tier 2s, and so on, and that was pretty much cast in stone, right? And now with the move to what you described as a case, suddenly we have sharing economy, we have new players coming in, who are basically turning this whole OEM tier 1 type of hierarchy upside down. Everybody's looking for new ways of basically leveraging these new technical capabilities, the business models, and of course the technical functions. People are looking at how do we do this in a safe and secure way and so on. So at the moment, really, it feels like everything is shaken, not stirred.
Right. So the changes that you guys have described, right? They're especially profound in automotive because automotive has this really deep supply chain, and it seems to me that a lot of the impact here is that historically the supply chain has been a steady state, like you mentioned. It's been hardware based, but now we're switching into software, right? Is that the nature of these challenges? Is that suddenly, we need to deal with the software, and it's sort of a mind shift, for the OEMs and for the supply chain. How does that factor into it? Is that one of the challenges? Is that something that we can adjust to? Is that the reason that you've suddenly seen this turmoil recently?
Yeah, so it's exactly that, like you say. For before we had basically a car manufacturer is an integrator for hardware, even with the upcoming ECUs and the software inside these ECUs, it still comes as a package, and it's mostly isolated and tested, and then the manufacturer does the overall integration. But now basically the functionality is removed from the hardware. So now you have a complete software ecosystem. And you need to, and also from different suppliers, yeah. First of all, the suppliers inside the car, but then also adjacent suppliers for like charging stations and so on. And then now the main focus will be that of a software integrator. Yeah. How do you manage the challenges? And exactly as Dirk said, it's not only a technical challenge, it's also a big part of an organizational challenge. Yeah. Because before you had like these kind of silos which were responsible for different parts of the car or of the car functionality, and now this all gets connected with each other, and that means also the people have to get connected to each other.
Yeah. I would argue it's even worse. It's not only about software, it is about distributed software.
Mm-hmm.
Right? I mean, everybody's talking about autonomous driving, and yes, we do need autonomous features in vehicles that can react in real time to something happening right ahead of us. But on the other hand, actually what we really want is distributed solutions where we get as much as possible information from the cloud with the latest data on road conditions, traffic ahead of us, etc. So, distributed systems are completely different beast from a centralized software system. So I would argue, yes, software-defined vehicle, so moving from logic basically burned into chips to higher-level functions like FPGAs, or then even high-level logic, that's one huge step. But then adding distribution to this, and as you said earlier on, like adding cloud functionality to this, that's a completely different thing, technically, but also culturally, right? I come from software, and when I first joined a huge manufacturer, it was a real culture shock for me, because I think people who come from software and who have a pure cloud background, they go and think like, yeah, let's release an MVP and then see how people like it, and then next week or tomorrow, we upgrade and patch and we see how it goes, and you gradually evolve your system. So if you talk to somebody with a manufacturing background, what's the MVP of a car, right? So I would say everybody who has a manufacturing background, I always believe they have a tattoo here that says SOP, start of production, because after the SOP, it's so incredibly more hard to actually move things to advanced functionality. And that's something we need to balance out culture-wise, but also functionality-wise. I think some people are taking risks. So if you look, for example, at the mobile phone manufacturers, right? They increasingly add sensor capabilities to their mobile phones without knowing exactly what they will be used for, right? And then they rely on app stores and creative developers to develop cool new functionality around these sensors, right? And I think the automotive industry is still a little bit away from this, but we do see some automotive players who are building some hardware into cars, right? And then basically use OTA, over-the-air updates to gradually basically enhance the functionality and to get all of this right, to basically switch from traditional development models to like an integrated DevOps in these kind of distributed systems, and to actually get this also safe and secure. So basically adopt your V&V processes, verification, validation, etc. That's a huge challenge. I mean, I don't know if I would ask you only what's happening in the area of ISO 26262, the move from ASIL to ZUTIF, etc. I mean, that must keep you busy even at weekends, I would assume.
Yes, that's true. That's a challenge by itself, but also it's interesting how does it merge with the standards and regulations that are outside the car. So these are car-based regulations, but then you have, for example, a car in a plant, then you have a different SIL standards, and how does it work together. And I like the analogy, or I think a lot of innovation obviously is driven by customer expectations, and nowadays the customer expects something like you said, like a smartphone where you introduce the app and then you get the cool new functionality. So in the car it's a little bit different because now it's like you have like say 20, 30 apps that work together, and they're from different manufacturers. They have to work together, they have to be secure together, they have to provide safety, because you, if it doesn't, then you get into a hazardous situation. And which is also important is you have a strong regulations on that. So you have to certify your software combination each time you change the software. So now you have companies like Facebook or Amazon that change software like hundreds of times per day. Like continuous integration, continuous development are these topics there. But I think you also need continuous certification, because how do you make sure if you do these software changes all the time that your car is still certified? Just an example, combustion engine, everybody knows the discussion. It's also actually true for so for electric cars. So there's the car will be certified to a certain resource level. And so if you change any functionality, then this could change, and then the car is not allowed to drive anymore by regulation. So, but you can think, okay, that's just a problem of the battery management system or of the motor management system, but it's not. Actually, if you bring in new software into the head unit or into the aux heat, into the heating system, this will have an impact on your on the resource consumption that you have. So all of this factors into the basically certification of your software. So that's a real challenge, I think, and that's a little different from what you have in an app store, where you have really a closed app, that is working by itself. It's not connected to the other app or to outside systems.
Right, and so I have a 2016 Dodge truck, and it does have apps in it, right? But it's very different, right? They are very specific. You can tell they've been tested very deeply. But the use cases that you guys are talking about, some of these get pretty advanced. You mentioned the parking garage, right? So now there's a vehicle, there is a infrastructure that knows about the parking garage, right? This is not any parking garage. This is a specific parking garage, and it's tracking, where's there a parking spot? Where are we going to put this vehicle? How are we going to get it there? I mean, there must be a lot of complexity in there. Is there sufficient capability to do that? I mean, you have to. How do you address that level of complexity?
I think that in this case, so right now we're in the situation that for each of these use cases, we have to develop everything from the ground up. So we have to make sure that the security level is fine. So we have to talk to the other system owner. What kind of security solution do we implement? We implement the security solution, certificate-based or whatever. And so we have to build everything from scratch. Obviously, that's a really hard task, and it's specific for that solution. So what we would need is some kind of abstraction layer where we would have, like say, a standard on the security where we could build upon this and then build much more easily such a distributed system over different suppliers of this. Because the overall system is not the car and it's not the parking garage, it's the car with the parking garage. And then also interesting questions, I think, is of obviously who is insuring this system, who is responsible at what time, is there overall responsibility? These are the questions that are not solved yet, I think.
Well, certainly the driver at some point is not the one controlling the vehicle, so the insurance of the driver may not make sense at some point, so there's certainly a transition there that has to happen. But another transition that's in place there is the OEM defines the architecture and the requirements, right? The suppliers actually have to do the implementation, right? So parking garages, that's one example, right? That's one use case, and the way he was describing it, that sounds very complicated, right? I wonder if the architecture and the requirements will provide sufficient implementation there, or if it really falls to the suppliers at some point to go figure this out, right? Is it the parking garage? Is it the supplier? Where does this come from?
I think it's a step-by-step evolution. I mean, we've all seen the cool videos you see on YouTube with very advanced autonomous driving functionality that's done in controlled environments. But actually to get it from this kind of like experimentation environment into the normal world that we all live in, and actually to get these things certified, that's still some way to go. And I think because you mentioned parking garage, that's really interesting. Actually, I was up on stage last year with Dieter Zetsche and Volkmar Denner, where we jointly presented the autonomous parking functionality with a Mercedes E-Class, and I had to test it the week before, right? And so we had 30 engineers standing around saying like, okay, Dirk, it's safe, throw yourself in front of the car. And I was like, are you sure? And so we did this. It's all good, and I think it's an amazing use case because it's, for me, the first step into the real world, and it has the advantage that a parking garage you can control. You can control who is actually allowed to be in it or not. You can even have like a completely empty parking garage where you can really roll out real world examples like stopping in front of the airport or the train station, and then your car basically parks itself in a controlled environment in a parking house. And that for me is one really interesting example of a first step that we can realistically go in a relatively short time. And then from there, I mean, obviously we're all aware of the SAE levels 3, 4, 5, etc. But it's kind of like step by step, gradual, and I think that's a good starting point.
Mm-hmm. Well, so that's a good starting point, right? And then we have all of the different levels, and there's we talked about one specific use case there. So parking garages, right? There will be other use cases. And these technologies can come together and start to be implemented. But at what point is there a complexity where the combination of these things cause problems? So add one component plus another component, and suddenly there might be a safety issue there, or a privacy issue, or a security issue, right? We have a supplier, but there are multiple suppliers to an OEM, right? Does that become a difficult problem to address the totality there, because there's a lot of complexity being added at the supplier level, and then at the OEM level, you need to make sense of this and to verify it and validate it and really understand what all the interactions are. that is not unique to automotive. That's been a software trend over time now. But does that present a special challenge?
So we were talking about innovation drivers, and first of all, the customer expectations. Then we said regulations are also basically can be an innovation driver. And I think what you alluded to is also innovation driver, and that's the increasing complexity of the system. So as we said before, we used to have like basically separated systems that did not communicate very much, and now we have distributed systems. We have systems of systems, and then we have different systems of systems talking to each other. And so if you know how complex it is to build software for a small distributed system, it seems like it's not possible anymore. But then there are examples from technologies that are already very far advanced that we don't even think about anymore, which show that you can solve this. There's an easy example that I like to give is the power plug that you have at your home. It's an interface, it's an API. So you just plug in and you know what you will get out. You get out your power, you have a certain voltage and everything. That's all you need to care about. The whole complexity behind this, all the power plants, how they manage to keep this voltage the way it is, ramping up plants and ramping down, and the complete network management, you don't care about. And you can build a system behind this power plug that doesn't know anything about the whole power plant complexity. So I think that's basically what has to be done. There have to be really clear-cut APIs between the systems, reliable APIs that might be standardized, or at least the frameworks are standardized, so that you don't carry the complexity from one part of the system into all the other parts, so that you can really rely on what comes out of your plug.
I've spent the first half of my career in kind of boring enterprise IT, meaning banking, insurance, telcos, etc. And when I think of what I have learned from my friends at Uetlihof in Zurich, for example, is that we manage complexity in enterprise IT on different levels. So on the lowest level, we have heavily invested in models and abstractions, like from UML to model-based type of systems. Then one level above, where we have like component-to-component interaction, like you said, we've invented SOA. We're not allowed to use this word anymore, but now we're talking about microservices and clean APIs, etc. And then on the level above that, when you really look at your entire application landscape from the perspective of the CIO, we have come up with best practices for enterprise architecture management, TOGAF, Archimate, these kind of things that really help on the CIO level to manage your application landscape. And I have a feeling that in automotive, actually, we can learn from that, because when I look at the complexity of a bank or a insurance company, that you nearly have the same level of complexity in terms of components distributed on the car, in terms of heterogeneity, in terms of distribution by connecting to the cloud, etc., that we actually have in enterprise components or in enterprise software systems. So maybe there's something in there that we can also take to automotive. So really thinking about enterprise architecture management to actually look at the vehicle holistically and manage all of these dependencies that you were referring to.
Right, so there are a lot of dependencies in there, and the technology is changing fairly rapidly. So what happens when you need a refresh, right? You need to do an update, right? So now we're not talking about enterprise systems where, as you mentioned before, you can do these updates and there's very minimal downside. If something didn't go right, you just do another update, nobody notices, it just gets better over time. But here we're talking about vehicles, we're talking about safety, we're talking about security, we're talking about reliability. These things can't go wrong. Are there challenges there for updating these apps, especially since the traditional IT approaches don't work specifically in automotive, that there need to be a little bit of adjustment?
Yes, it's a big challenge. First of all, I think there will be different levels of apps. So like entertainment apps obviously don't need to have the taken the same care of than apps that are going deep into the car functionality, like assisted driving apps, for example, where you really go into the braking system or into the steering system. But you have to, we were talking about certification before, you have to make sure that the software combination in the car is a valid one, and only, and it could be different ones, but they all have to be valid. So you have to make really sure you have to have a dependency management, you have to have a software release management, basically, and you have to be able to make sure that always a certified and tested software combination is in the car, because it's not really about one single software piece on one single part, but it's rather the combination of these that makes it difficult. And I think the important thing is that not each application is supposed to build this by themselves like it's now, but we have to have some kind of foundation where the application development can base on, so that you have a faster development cycle.
Mm-hmm.
From the supplier side, I fully agree with everything you said. I think for us that represented a business opportunity. So for example, we have invested in OTA infrastructure, so we have built systems that really manage collecting updates, validating them, bundling them, defining update policies. So one example for a policy or rule that you can define is that certain updates, depending on the category that you just mentioned, if it's a update that, if it goes wrong, potentially could basically mean that you can't move your car anymore, then we basically try to find out if you're not in the middle of the desert, because that would be bad. Yeah? But make sure that you're close to somewhere that, in case something unexpected goes wrong, we can help. And then obviously the distribution starts with regional distribution. So if you have updates that are cross-country, right? So how do you basically move these bundles across countries, and especially when you look east-west globally, that there's some big firewall challenges there. And then last but not least, obviously, the last mile to the car, and then actually the actual distribution of the packages on the car, right? So we're trying to basically build kind of like a hierarchical management model of all the components on the car, so that we can basically then distribute the components to the different ECUs, CCUs, etc. on the car. And the OTA infrastructure has really now become very sophisticated software platform. So for us, that's a category like, let's say, ERP or CRM or something like this. Right? It's a category on its own.
Yeah. It's so interesting that you mentioned, that you mentioned the different countries or regions, because there you could also have functionality that's allowed in one country or region and not allowed in another one. So you have the configuration management, so which combination of functionality is allowed, and automatically changing it when you're crossing the border. One example is, for example, taking pictures when you have somebody drives into your car. That's allowed in some countries, but it's not allowed in other countries. So how do you make sure that the functionality is really turned off as you cross the border? Yeah.
So it needs to be geolocation aware. Okay, so observation. Tell me if I understand this correctly. Okay, so we have the OEM, right? And you have the architecture, you have the requirements. So say for something like over-the-air updates, you actually perform the over-the-air update to get the software down to the vehicle. You were mentioning the policies, right? So you're a supplier, very large supplier, you probably support many OEMs, right? So you're the OEM, you have many suppliers here. So the question that I have then is is there a bit of a misconfiguration there, that you have solutions that you're trying to adapt to multiple OEMs that probably have different requirements. you have certain requirements and you're trying to get your entire supply chain to sort of conform to them. Is there a little bit of a mismatch there on you're trying to service all of the OEMs and then you're trying to service all of the suppliers, and is there a potential there where the complexity might creep back in and it might be time for a standard or some way to sort of normalize this? Do you see a complexity that might require standardization at some point to iron out, because you both have a one-to-many, which turns into a many-to-many join there when you actually start rolling these out in practice, if I'm understanding it correctly?
You want to start?
Yeah, I think that's definitely something we need to look at over time, because I think these OTA platforms that I was just mentioning, they need to be neutral, and at the end of the day, it's the OEMs who have to make up the rules. We can only provide the infrastructure, and as you said, software updates, packages, bundles can come from multiple tier 1s, tier 2s, etc. So, you have to deal with a high level of technical heterogeneity there also. So I think over time, it really would make sense to consider increasing the level of harmonization and standardization there.
Mm-hmm.
I agree on the standardization, force towards standardization there. I think that would help. First of all, one has to think about what really to standardize to make this, so at what level. You don't want to make it too high, then the system is too confined, you don't want to set it too low. But there's also some other approach where usually we have a lot of ECUs, like 100 ECUs inside the car, and they're all developed basically for each car, not each model line basically, and each generation, they're developed from scratch. So you have new suppliers and they basically develop the functionality from scratch. That's mostly the current situation, and obviously it has disadvantages. It has advantages, but it also, because you can incorporate new technology easier and so on, but it also has disadvantages, because if you have complex systems, connected systems, and you have security issues and things like that, if you develop it every time you develop it new, then you always have this chance that these problems occur again, that you might have solved in the last generation. So I think it's moving towards more towards an in-car platform approach, where you have some more capable compute devices that are setting basically a platform layer that can handle OTA, that can handle security and so on. And this one is pretty stable, or it evolves over the generations and over the model lines. On top of this, there's the functionality, the applications sitting. And so you basically are writing these applications anew, but your foundation, your platform is much more stable than it used to be. So you also take out this, and this would be kind of a standardization, because then you can, then somebody can adapt, or it's easier to adapt between supplier and everybody, different systems, different OEMs, if one can agree on this platform abstraction. Even if the platform is not exactly the same, again, if you have certain APIs and certain abstraction levels, you might have this right abstraction to it's different than standardization. It's a kind of a standardization on the API layer, but not standardizing everything.
Right, and so something in there has to happen in order to have the two sides that are doing a many-to-many come together in the middle. So we talked a little bit about how we got here, right, and the history of the automotive and the changes that are happening now. How do you see this going forward? What do we have coming at us for? So we've talked about the certification, we talked about the standardization, we talked about the technology shifts. What do we have coming at us here that'll be fun, exciting, and new and different, concerning potentially?
It's obviously an interesting question and hard to answer. I see. So if we look at the car together with let's say the cloud around, then or let's compare the car to the cloud. So the car by itself is also a kind of a data center. Yeah. So like it's actually a more old-fashioned data center, because you have different devices that talk like some low-level protocols with each other. And now we're coming into the times where you start to have virtualization, so something that you also had in the data centers. So that's kind of some abstraction. But I think we need to get one level even above to have a cloud approach inside the car. So there you have this abstraction that I was talking about. So if you writing applications in the cloud, you don't have to care about anything of your hardware, and you just spin up some resources and things like that. That's something that I see coming into the car and bringing all kinds of advantages from the software development side. These are like the new technologies in software development. How do you do this? How do you do logging? How do you do all this kind of dependency management? But it has to be adapted to the car or the transport systems because of safety. Security is something that comes with it, but safety and the different regulations and so on. But basically, the projection would be a seamless cloud from the back-end cloud to the car cloud, and even shifting functionality between the cloud and the car. I was talking about the speech recognition. So if you have connectivity, then you can move your speech recognition into the cloud, and you obviously have much better compute. And then if you don't have connectivity, you move it back into the car, and things like that.
Interesting. Yeah, that'll be great. I'm looking forward to that. So, any closing comments before we grab a couple of questions? No? Okay. So we have a few minutes left here. Does anybody have any questions for our panelists? Question right here. I don't know if we have a microphone, so you might have to just holler, and I'll repeat the question. Oh, here we go. Here comes the microphone.
So my question is about...
Could you tell us who you are and where you're from?
I'm Oscar Nadas. I've worked in automotive for quite a few years as program manager and both in OEM and tier ones. And my question is around value, specifically not only retaining your current value as a brand or as a company, but also increasing, hopefully, specifically the shift from hardware to software. So we're currently seeing in other industries, the most obvious being mobile devices, how hardware has almost become commoditized. Hardware manufacturers have lost most of their leveraging power, and it's very much dependent on the software for the end customer. And so how do you see that in automotive, which we're beginning to see that shift? Obviously, Mercedes-Benz has tremendous brand value right now, and has had for many, many years. But also Bosch. People do see Bosch very much as a very high-quality component, almost like an Intel in computers. How do you work towards retaining that value as we shift towards more and more software development or the software offered to the end customer as the important part of that value when they purchase or pay for the service?
It's an interesting and hard question to answer. I think actually so one is used to, as you said, one is used to have hardware which defines the costs and then and which is paid by the customer, and it comes with some software. But maybe it has to change, and because the value itself of the software is increasing. So basically, in the future, the customer might have to pay the price for the software more than of the hardware that is underneath the software. So I think it calls really, as you said, for new models. But what's the outcome? I don't know. But I think there needs to be a change.
I agree. At the end of the day, this is about cultural change, where we need to develop a culture that very carefully balances the rigor and basically everything that we have adopted in the last 130 years. We were talking about earlier on, to make sure that the products we deliver are of the highest quality, and combine that with more and more agile innovation and striking that balance and developing a culture that allows us to basically deliver high quality solutions in ever increasing frequencies and support new business models, etc. I think that's the challenge and the opportunity.
Yeah, yeah. Good question. Thank you for that. I think we've reached the end of our time limit here. So if I could ask for a round of applause for our fabulous panelists here. Thank you very much. Thank you for coming out and spending time with us today here at IoT Solutions World Congress. Thank you.